Hello my friends! Alright, so let's implement quickly and efficiently the linear regression model on the whole dataset. First, a quick reminder on what is the linear regression model that we're about to build. We're simply about to build this one, right? Because we have only one feature, which is the position levels, and the dependent variable, which is of course the salary to predict. Alright? So that's what we'll do first, and then we'll of course implement the polynomial regression model with, I will tell you how many powers of that same position level feature. Okay, so let's do this, starting by creating a new code cell. Alright, so I hope you did it yourself first to make sure you refresh your skills. And so if that's the case, of course you started from the scikit-learn library, because that's the library that contains this linear regression class which allows to build the linear regression model. So scikit-learn, from which we're going to get access to the linear model which contains this class, and from this linear model we're going to import the linear regression class, as Google Colab guesses perfectly. Perfect, so that's the first step. Then we're going to create an object of this class. So I know we used to call it regressor, but this time, since we're going to have two regressors, we're going to have the linear regression regressor and the polynomial regression regressor. Therefore, this time I'm going to call it linreg for linear regressor. Okay, so linreg will be created as an object of this linear regression class. So I'm copying and pasting that here, adding some parentheses. And remember, we don't have to input anything in these parentheses because there is not much to tune in the linear regression model. Good. And finally, now we have, the linear regression model, but it is not smart yet. It is not trained yet on this data set, to understand and learn the correlations between the position levels and the salaries. So that's what we're going to do right now by using this fit method, which is exactly a training method that will train the model on these data. All right. So to do this, we're going to call our object first, linreg, from which we're going to call the fit method, which, remember, has to take as input the couple of matrix of features and dependent variable vector of the training set, right? That's what we did before, but remember here that we didn't split the data set into a training set and a test set because we want to leverage the maximum data in order to train our model, and therefore this time we're going to take the whole matrix of features x and the whole dependent variable vector y. All right, so here we just input x and y, and there we go, we built the linear regression model in a flashlight. So we're going to execute this. Here we go, and now we have not only our model but also a trained model on this data set. Okay, great. Now we're going to close this and we're going to focus on the heart of the matter, which is the polynomial regression model. I'm going to teach you now how to build the polynomial regression model. All right, so we're going to create a new code cell, and now we're going to go back to this slide to explain exactly what we're going to do. All right, so as you understand, what we've just built so far is this model. We only have one feature, the position levels, and the dependent variable vector to predict, which are the salaries. Now, what we're going to do is we're going to create a multiple linear regression model, but instead of having different features, x1, x2, and xn, well, these features will be x1, x1 squared, and x1 at the power of n. And we'll actually tune this parameter n a bit to try several powers. So not to confuse, the polynomial linear regression is not a linear model because you will see that it can learn some nonlinear correlations, but we call it polynomial linear regression because indeed there is this linear combination of the squared and powered features, x1, x1 squared, and x1 at the power of n. All right, and so the process of building this model on Python will be first to create a matrix of the powered features, a matrix of features but not containing different features like x1, x2, and xn, but a matrix of features containing x1 as a first feature, then x1 squared as a second feature, and then x1 at the power of n as an nth feature. So that will be our matrix of features, and we will call it xpoly. And then we will create a linear regressor object, from the linear regression class, to integrate these powered features of this matrix of features in this new linear regressor. You see the idea? So it's a building process in two steps. We're going to first create the matrix of features containing these features at different powers, and then we'll integrate that into a linear regression model, because indeed this is a linear combination of these powered features. All right, perfect. So let's do this. First step. The first step is to actually import this tool that will allow us to create this matrix of powered features. You know, x1, x1 squared, and x1 at the power of n. And this class is called polynomial feature. So we're going to import it first, which we can get from, once again, of course, the scikit-learn library. There we go. But this time, we're going to get access to the pre-processing module, which contains that polynomial features class. This is a class because indeed, we're kind of pre-processing our x1 feature because we want to create out of x1, well, x1, x1 squared, and x1 at the power of n. So we're kind of doing pre-processing of the features. All right, so from this pre-processing module, we're going to import, well, that class polynomial features. Perfect. I really like Google Colab. So polynomial features. And then, of course, well, you know, anytime we import a class, the next step is to, of course, create an object of this class. And this object will be exactly the tool that will allow us to create this matrix of the features x1, x1 squared, x1 at the power of n. I will precise what n we choose then. We will choose several of them. But there you go. That's what we build with this polynomial features class. And so, well, we're going to call this object of this class poly_reg. As polynomial regressor, but it's not exactly the regressor itself because, you know, the final polynomial regressor will be the combination of this matrix of powered features and the linear regressor, and that's why we will call it actually linreg2, you will see. So polyreg will be created as an instance or an object of this polynomial features class. So we're going to paste that here, adding some parentheses, and that is where we're going to choose the n. You know that n here is exactly chosen in this new class. So first we're going to start with 2, okay? We're going to build a polynomial regression model resulting from the equation y equals b0 plus b1 x1 plus b2 x1 squared, where x1 is of course the position levels and y is the salaries. All right, so let's create this. Let's precise degree, which is the name of the parameter for that n, equals 2, and then we'll try 3 and 4, okay? Then, next step. Well, the next step is now to proceed to this transformation of this simple matrix of features containing only x1, meaning exactly this column. So far, this is our matrix of features of only one feature. And now we're going to transform this matrix of a single feature into this new matrix of features containing x1 as a first feature, x1 squared as a second feature, and then that's it, because so far we started with n equal 2. But if we chose, for example, n equal 3, well, the matrix of features would be x1, x1 squared, and x1 at the power of 3. All right? So that's what we're going to do. And to do this, well, we're going to take, of course, our polyreg object again, from which we're going to call the method fitTransform again. You're starting to know this method. That's, you know, the method that usually proceeds to a transformation. And here, the transformation is to turn this matrix of a single feature into this new matrix of features composed of x1 as the first feature and x1 squared as the second feature. All right? fitTransform, then some parentheses. And then according to you now, what do we have to input here? Well, that's pretty obvious. That's exactly the matrix of features we want to transform into this matrix of squared features, let's say, right? So x of course, that's what we want to transform. X so far is only composed of this column. Okay, so fitTransform x, and now we have our new matrix of features. However, this exactly returns this new matrix of features, so now we're going to create a new variable which will be this new matrix of features itself, and we're going to call it x_poly equals what is returned by this fitTransform method applied to x. Great, so now we have exactly the matrix of features composed of the position levels and the squares of the position levels. Good. So now, according to you, what are we going to do? Well, as I said at the beginning, it's like now we have a new matrix of features, you know, composed of these two variables here. And well, very simply, we just have to build a linear regression model that will integrate these features into this equation. Y equals b0 plus b1 x1 plus b2 x1 squared. Right? You see the idea? That's where the linear comes from. And therefore, well, you know what to do. You know how to create such a linear regressor, but we have to create a new one, which is of course different than this one, because this one is already trained on this matrix of single feature x, and therefore having already learned coefficient. So now we need to create a new one, which we're going to call, of course, lin reg, and I'm adding underscore 2, which therefore will be a new object of this linear regression class, adding some parentheses. And well, this object will be now trained on this new matrix of features composed of the position levels at different powers, and of course then the salary, because indeed we need the dependent variable vector to train the linear regression model and any machine learning model. Alright, so the next step and final step is to of course call this new linear regressor object that we've just created, from which we're going to call the fit method, which will take as input, of course, this new matrix of features containing the position levels at different powers, and of course the same dependent variable vector, which are the salaries. Alright, so let's do this. Let's input first x poly and then y, and there you go, you have your polynomial regression model. Congratulations! Now you know how to build a nonlinear regression model, and that's what we're going to see clearly with the next steps when visualizing the linear regression results first and the polynomial regression results. Now you know how to build such a model, and you have them in the toolkit. So you're getting more power in machine learning, more knowledge, more skills. Congratulations! That's amazing, and now I can't wait to move on to the next tutorial to show you indeed the different results we get with linear regression and polynomial regression. So I'll see you in the next tutorial. Let's quickly run this cell in order to, get the model itself. And now whenever you're ready, let's proceed to the next tutorial for the visualizations. And until then, enjoy machine learning.